So if you want to prove that this equation is homogeneous or it is dimensionally correct, we have in this equation 2as equal v square minus u square. So first we'll write the units. The 2 is a number. That this 2 does not have, it's a part of the formula, but it does not have any unit. It's just a number, a constant. So it does not have any unit. That's why we did not write anything. What about the second one? That's acceleration. So the unit of acceleration is meter per second square. S is representing the distance. The unit of the distance is meter. V is representing the speed, and square is there. So it will be meter. The unit is meter per second, and then whole square. Minus U is also representing the speed, which is meter per second and square. When we simplify meter multiplied with meter, that will be meter square divided by second square. We'll simplify first the units. So this will be square. So this will turn out to be. What about 2? Why did not write anything for 2? Because 2 is a number. This number does not have any unit, like it's not representing any physical quantity with a unit. That's why we did not mention anything for this 2. So if any equation involve a number, if any number is written in the equation, that does not have any unit. That's why we did not list any unit for this 2. So this will be a meter square over divided by second square minus meter square over second square. Now, till here, we simplified the unit. Like we cannot further simplify the unit. Now we'll start writing the dimension. So if we write the dimension, the meter is representing the length. So this will be a length square, the time square, length square over time square minus length square over time square. Now, the left-hand side is already L by T square, which is simplified. The right-hand side, we can simplify. So on the left-hand side, we already have. But on the right-hand side, if I take T square as an LCM, dimensions will further simplify. So T square is an LCM. So this will be L square minus L square. What is L square minus L square in dimensions? What will the result of L square minus L square? In a dimension L minus L, L plus L, both will be L. So if L square minus L square or L square plus L square, that will be L square. So this will be L square over T square. And then it will be, if we sum L square T minus 2, and this will be L square T raised to the power minus 2. So this equation is dimensionally correct. Is it clear, this example? Any doubt in this?
Yes. Yes, sir.
Yes, Shamir, any doubt? Mubashir, Mira, Fabia, Aisha, any doubt?
No, sir.
Okay. Then we have another equation. S is equals to U plus A, where S is a distance, U is the speed, the initial speed or the starting speed, and A is the acceleration. You have to check this equation is dimensionally correct or incorrect. Just in your answer, just say yes or no. Solve and try, just say yes or no. Is this dimensionally correct or incorrect? S equal U plus A. Is this dimensionally correct or incorrect? Yeah, so most of you answered that it is dimensionally incorrect as the units are not same. So this equation is not dimensionally correct because when we write the unit itself, the unit of a distance is meter. Here it will be meter per second, and here it will be meter per second square. And when when you simplify, it must be simplified in terms of the dimension. Like after writing the units, now we cannot further simplify the units. So now we will simplify the, yes, Shahir, any question? You have a maths class at what time? 3? It's every Friday or Saturday? Okay, we will conclude the session. You can leave the session. The session is recorded. I'm not explaining anything extra other than this. And then we'll do some more examples and the MCQs as well. So you can leave the session and take the maths class. So after writing the units, here we wrote the units we cannot simplify, and then we'll simplify the dimensions we'll mention. So unit of the length is meter, unit meter time, and here L T square. So the T square will be the LCM. So this will become LT plus L. And this LT plus L cannot be solved further. Why? Because LT is having a different dimension, L is having a different dimension. So even from the beginning, the units are not same, as well as the right hand side and the left hand side dimension are not same. So this equation is not dimensionally correct. So if you find different dimensions, that also means that it is not incorrect. So whenever you want to check the equation is dimensionally correct or incorrect, you first write the units and then you write the dimension. Now, if you want to derive a physical equation, like example, say you want to find a relation between the time period of a pendulum. A pendulum is there if a mass is attached to a string and it oscillates to and fro. So there's a mass attached to a string and it oscillates to and fro. The time it takes to move from one end to another and come back, that's known as the period of oscillation or the time period. You did the experiment and you're predicting, example, you're finding a relation that what equation can relate the time period, the length, and the gravity. So you're finding what is the effect of the length on the time period, and you're finding what is the effect of the gravity on the time period, but you don't know the equation. Like there is an equation, but what if you don't know the equation and you want to make a relation between the time period and the length and the gravity? So how it can be done? So if I'm finding the relation between the time period and the length, so I will say the time period example is directly proportional to length raised to power x. X can be any value. We don't know, that's why we call that as x. And a second relation I'm finding that the relation between the time period and the gravity. So I said the time period is directly proportional to gravity raised to power y. So whenever we want to derive any equation, we want to establish a relation between the two quantities. So we use a proportionality relation. They can have inverse proportion. They can, but we assume that example, the proportion is direct raised to power n, like x, y, or z. So we are finding what is the relation between the time period and the length and the time period and gravity. So we said the time period is proportional to length raised to power x, and the time period is related to gravity raised to power y. Because x can be anything. X can be 1, x can be 0. If there was no relation, for example, time period related to length raised to power x. So if x is 0, x does not have any value. If x is 0, anything raised to power 0 is 1. So if it means the time period and length will not have a relation. But what if the value of the x is 1? If you got solve and you get the value of x is equals to 1, so t raised to power L raised to power 1. So it means time period is directly proportional to length. What if you get the value of x is minus 1? So if you get the value of x minus 1, so t is proportional to L raised to power minus 1, or you can say t is inversely proportional to L. Or it can be square, it can be power minus 2, any power is there. So you're establishing a relation. So if you want to establish a relation between time period with length and gravity, so how you will establish a relation? You will say that the time period is directly proportional to first quantity raised to power x, and it is proportional to second quantity raised to power y. If there was a third quantity, I will say z. If fourth quantity, I can say a, b, c. Even I can use, instead of x and y, you can also use the letter a and b. Does not make difference. So if I combine these two relations, I can also say that the time period is proportional to length raised to power x and gravity raised to power y. And in mathematics, the rule is that whenever we replace the proportionality sign, like if I have x is proportional to y, whenever I replace the proportionality sign, we replace with equal to and a constant. So I will say x is equals to k y, where k is a constant. So this is a rule. The mathematical rule is that whenever a proportionality sign is replaced from the equation, it must be replaced with a equal to and any constant. That constant can have any number, any value, but it should be there as a part of the equation. So whenever we replace the proportionality sign, we replace with equal to and the constant. So we can say t is equals to k raised to power, sorry, k L raised to power x and g raised to power y. So whenever we want to establish a relation, this is a way to establish a relation. This is a scientific way to form an equation, to derive any equation. So we are finding the effect of the length on the time period, and we are finding the effect of the gravity on the time period. So the two physical quantities, I will always relate them with a proportionality sign and the power. So first I say the time period example. We took an example. This is a scientific way to derive an equation. So we took the time period is directly proportional to length raised to power x, and the time period is directly proportional to g raised to power y, because I am establishing a relation between the length and the gravity. No, we are establishing a relation of between the time period and length and time period and gravity. So the common factor is a time period here. That's why we establish a relation, the time period proportional to length raised to power x and the time period proportional to gravity raised to power y. Is it clear till this point? The proportionality relation? Now we will simplify. Now how to solve here? I'm coming to that point. Now how to solve after establishing a relation and forming the equation, we will write the units. So time, what is the unit of the time? Seconds. So we write second here. So we write second. K is a constant. So we don't know its unit, like we don't include that K in the units. It's just a constant. Because it can have unit, it may not have a unit, but it's just a part of a mathematical equation. What about length? What is the unit of the length? The unit of the length is meter, so we write m. And what is the power x? So we write m raised to power x. Gravity or acceleration due to gravity. What is the unit of the gravity? The unit of the gravity is meter per second square, or ms minus 2. So in place of a gravity, I can write ms minus 2, the unit of the gravity, and raised to power y. So this is raised to power y. Now we simplify. This will be s. This will be m raised to power x. This will be, because this y is multiplied, this will be m raised to power y. And this will be s raised to power minus 2y. Is it clear till this point, the solution? Anyone having a doubt or a question? Now, we can further simplify. Yeah, no k, because k is a constant. It's just a mathematical constant is there, constant of the proportionality. So we don't include anything. It can have a dimension, but it cannot be taken right now. When we are finding a relation of the quantity between the quantity, we ignore k in that case. So this will be second, this will be m, this will be m x plus y, and this will be second minus 2, like minus 2y. Now what we do, we compare the left hand side and the right hand side. If I compare the left hand side and the right hand side, here, what is the power of the second? The second power is 1. Okay. And here, what is the power of the second? Minus 2y. So I can say 1 is equals to minus 2y. Because on the left hand side, the power of the second is 1. On the right hand side, the power of the second is minus 2. So one, we have one, other side we have minus 2. So we can say, because the second is a unit, so their power, because to be dimensionally correct, for this equation to be dimensionally correct, the power of the second on the left hand side should be equals to power on the right hand side. So we can say that 1 should be equals to minus 2y. Or, and what about m? What is the power of the m here? We don't see m on the left hand side. It means m is raised to power 0, because m is not there on the left hand side. So m is 0 on the left hand side. And what about the right hand side? The right hand side, it is x plus y. So means m is equal, 0 is equals to x plus y. So we have the two equations. We can solve them simultaneously. So if 1 is equals to minus 2y, if I simplify this, so it will be 1 divided by, like, simply 1 divided by minus 2 is y, or y is equals to minus half. Is it clear, the value of the y? Any doubt in this? The value of the y. Any question or doubt till this point?
No, sir.
Any question or doubt? Okay. It's the same thing. Look, if I have 1 is equals to minus 2y, if I move other side, so it will become 1 plus 2y is equals to 0. If I move 1 here, so 2y is equals to minus 1. So y will be minus 1 by 2. So it's the same thing. It does not make difference. So we got the y is equals to minus half. What about the value of the x? We have the simultaneous equation. So because the first equation, we got the value of y. If I substitute here the value of the y, so 0 is equals to x. The value of the y is minus half. So 0 is equals to x minus half. Half will move other side. So 0 plus half is equals to x, or x is equals to half. So what does it mean? It means the value of the x is half, and the value of the y is minus half. So what will the equation now? The actual equation, so we have this equation, t is equals to k raised to power k l raised to power x and g raised to power y. So if I substitute the value of x and y, so L was the x value of x was half. So this is 1 by 2. And the value of the y is minus half, minus 1 by 2. If I move this in denominator and simplify the mathematical equation, so it will be L raised to power half and G raised to power half in denominator. What is the meaning of the term half? So it means it's a root, square root. So I can say T is equals to K under root L divided by under root G. So this is actually a mathematical equation which can relate the time period of a pendulum with the length of the pendulum and the gravity of the earth. So this is the final equation we get, which relate the time period with length and the time period with gravity. Is it clear, this one, or should I repeat? Anyone having a doubt or a question till this point? Muhammad Isa, Mirab, Imad, Hafsa, Ghulam.
Most likely.
Any question or doubt? Yeah, the gravity, because gravity's acceleration is there, they have the same unit. That's why falling object, we say the gravity is 9.8. So acceleration due to gravity is also 9.8. So the unit of the gravity, it's Newton per kilogram or meter per second square, which is same as acceleration. Any question or a doubt in this? Okay. Now, let's do another example. The speed of a sound in a medium depends on the wavelength, the Young's modulus, the density of a medium. So we want to relate them. So we want to relate the speed with all these factors. So I can say that speed is proportional to wavelength raised to power x. I can say speed can be related to the Young's modulus raised to power y. And I can say the speed is related to the density raised to power z. And if I combine all these, I can say speed is proportional to all of them, or I can say equal to a constant. K is a constant. So lambda raised to power x, the Young's modulus raised to power y, and the density raised to power z. Is it clear till this point? The relation between speed. So it can have any power. Yeah, we will always put them directly proportional. And at the last, when we simplify the equation, we may get, for example, if I get the value of x as minus half or minus 1, so it means it is inversely proportional. So we take always the directly proportional and simplify them and get the value for x, y, and z. So we have to write always in this manner. The value of x, y, if it's no relation between that quantity, then the final answer might be 0. X, y, and z all can be 0 as well. That's right. They all can be 0. It means maybe no relation. Now what we'll do, we'll write the units. So what will be the unit for the speed? The unit of the speed is meter per second. K will not write anything. What about the unit of the wavelength? It's a length. So it will be m. You can write all of them in numerator from the beginning, so you don't have to simplify further. I can write ms minus 1 here. This will not have, this will be length meter raised to power x. What about the other one? The Young's modulus unit is given to you in the question. So it is kilogram, meter minus 1, second minus 2. And then we have the last one is a density. What is the unit of a density? Kilogram per meter cube. So I can say kilogram, meter raised to power minus 3. So we'll simplify the equations, the units. So here meter is x, here meter is minus 1, and here meter is minus 3. But there is also a power is there, like this is raised to power x, this is raised to power y, and this is raised to power z. So this is m raised to power x. I'll further simplify. So this will be m raised to power x. This will be kilogram raised to power y, meter raised to power minus y, meter is second raised to power minus 2 y. And this will be kilogram raised to power z and minus 3z. Now, we just simplify the common m raised to power x, m raised to power minus y, and m raised to power minus 3z. So this will be m raised to power x minus y minus 3z. Then we have kg. It's up to you. Order is not that important. You can write, like example, second if you want to write. So second minus 2y is there. That's the only we have about the second. And then we have z, z is there. Means kilogram is there. So kilogram is raised to power, this is y, and this one is z. So I can say y plus z. And on our left hand side, you have ms minus 1, and kg does not have any. So it means kg is 0 here on the left hand side. It's not there. Now we simplify, we just compare. So if I compare kg, this is 0. So I can say 0 is equals to y plus z. That is one thing. And I can compare because it's 1 here for the meter. So I can say 1 equals, the whole equation is there. So on this side, it's 1. The other side is x minus y and minus 3z. And what about the second? It's minus 1 here. On the left hand side is minus 1. On the right hand side is minus 2y. So we have 3 equations. We can solve any one of them first, like A, B, and C if we say. So if I solve this equation, I'll get the value for the y. So if we simplify, this negative will cancel with negative. So y will be equal, this 2 will go there in division. So y will be 1 by 2. So the value of the y is half. Is it clear? The value of the y? Then how to work out the value of, if we have this equation, if I substitute the value of the y is equals to half. So this will be 0, half plus z. It will move other side. So what will this value of the z? This value of the z is minus half. So we get the value of a z as negative half or minus half. And now we just have to substitute here in equation B to get the value of x. Because if 1 equal x minus y minus 3z, so this will be 1 plus y plus 3z is equals to x. And we just substitute, so 1, the value of the y is half, and the value of the z is negative half, minus half. So we'll simplify the value of the x. I'll use this space here. So this will be 1 plus half and minus 3 by 2 is equals to x. So if I take 2 as an LCM, so this will be 2, 1 and minus 3 is equals to x. This will be 3 minus 3 divided by 2 is equals to x. So means x is 0. Because 3 minus 3 divided by 2, 3 minus 3 is 0. So 0 by 2 is 0. So means the value of x is 0. So the value of x is 0 means this does not depends on the x. So if we use the first equation here, this is the first equation. So means it does not depends on the wavelength. So the final equation will be V is equals to K lambda raised to power 0 because the value of x is 0. The Young's modulus raised to power y, the value of the y was half. So value of the y is half, and the value of the density is negative half. The z was negative half. So now we simplify because anything raised to power 0 is 1. So V equals K. This will be 1. We don't have to write. So this will be e raised to power half divided by, because this is a negative denominator, it will turn to positive. Or we can also say V is equals to K times e raised to power, like under root e divided by under root rho. So this is the actual equation which relate the speed of a sound in a medium, which depends on the Young's modulus and the density, but it does not depends on the wavelength. Is it clear? This second example, the derivation, that how we establish a relation between the physical quantities and derive an equation. Any question or doubt in this? Yeah, question say it depends on the wavelength, but when we establish a relation, it shows it does not depends on the wavelength. The relationship does not support that statement. Yeah, x minus y minus 3z is equals to 1. So we were having this, and that whole was equals to 1 when you simplify, because it was 1 is equals to x minus y minus 3z. Minus y and minus 3z, I move to other side. So 1 plus y plus 3z was equals to x. And then I substitute the value of a y and substitute the value of a z. I'll get the value for x. That whole is equals to 1. Is it clear? Any doubts? Now some questions related to the topic which we have discussed today. You will use the chat to answer the questions. Just a minute, I will share the file. Use the chat to answer the questions. First MCQ, which is not a SI base unit. Which is not the SI base unit. Yes, Muhammad Isa, what's your answer? Math. Ghulam. Ammar. So till now, everyone answered correctly. Which is not an SI base unit. Ampere. Yes, kilogram. Second, but coulomb is not, because it should, coulomb is not, it's a derived unit, not the base unit. What represents a physical quantity? Question 2. What represents a physical quantity? A characteristic to represent a physical quantity, there should be a numerical magnitude and there should be a unit. So 3 is just a magnitude. Kilogram is just a unit. It's not a representing a physical quantity. Physical quantity should have a numerical magnitude and a unit. That's why C will be the right answer. So there are more questions, but about a minute left. So that's it for today. Any question or a doubt you have related to the session?
Well said.
So tomorrow at the same time we'll start around 1:30. If you have any question or doubt, you can ask your doubts, send your doubts on WhatsApp, or during a session you can also ask. So I'll end the session and share the related recording.